Morning, everyone. Welcome to week 6 after the break for MATH13218 Advanced Applications of Mathematics. Today, we will discuss second order constant coefficient inhomogeneous linear ODEs. I am confident that by now, if you have done enough practice or kept the concept in your mind, you understand each of this word. Still, I'll explain it once again. Please note that in your notebook or your literature. So second order, that means we are talking about d2y by dx2, constant coefficients. So the multiple of this differential variable like dy by dx, d2y by dx2 are constant. Inhomogeneous, so the right-hand side is not zero. It contains some x terms or t terms, depends on a independent variable. And linear, they are not multiplied together. Ordinary differential equation, that means there is no partial derivative. Maybe we haven't introduced partial derivative, but if you follow some literature, you may find it in some of the literature that they mention about partial differential equation, but it's not covered in the unit. Right. So this is what we mean by second order. So you get 2, that is second order, right? Then you got constant coefficient, a and b are constant, and the right hand side is non-zero, and that's why it's called inhomogeneous. If it is zero, we call it homogeneous differential equation. And for this kind of equation, when it's inhomogeneous, we know our y is nothing but y for the homogeneous and yp the particular solution, right? And for this kind of homogeneous, we know our y edge is nothing but c1y1, c2y2 that we have seen last week. How to obtain it? I have put together a summary, which I'm going to explain in a bit. But let's look at some steps on how we find the general solution. So get the general solution to its corresponding homogeneous ODE that we call y edge by the means of characteristic equation. Remember that R equation which we get? So R square plus AR plus B is equal to 0. And there were 3 cases that we were dealing. If you go beyond second order, there might be 4th case as well. But for now, we are talking about 3 cases because we are restricting our discussion to 3 cases only. Second order, okay? Then we will get the particular solution yp related to fx, and then the general solution, which ygg for general, yh for the corresponding homogeneous ODE, and yp, that's the particular solution that will go. And if there is initial condition, we will also determine the constant a and b. There should be 2 conditions because it's second order, so you get 2 unknown, c1, c2 as discussed here, right? And that we will get it from the 2 initial conditions. Now, this is a summary of what we have already seen last week. So second order inhomogeneous, so y edge a summary. This is from week 5. I just put together everything, right? Copy and pasted the same thing that we discussed, so nothing new here. Case 1, 2 distinctive real roots. So different, distinctive, another word, different, right? They are not same. So your discriminant of that equation, a square minus 4b is greater than 0, not equal to 0. We are just restricting to greater than 0. So your y1 is e1 r1x when r1 and r2 are the roots, as we mentioned here. And another y2 is e power r2x. You can call it alpha, beta, you can call it CD, whatever you like. 2 roots, e power first root x, e power second root times x. And then we combined our y as c1 r1x, c2 r2x. We have seen plenty example last week. Please, when I say last week, week 5, not the previous week, the week earlier. Please revisit them. 2 repeated roots, r1 and r2 is r. A square minus 4b is 0. So when they are repeated, this doesn't help. Then you're talking e power rx, e power rx. Then it's the same and it becomes linearly dependent as discussed in, I think, week 4. where we are talking about they have to linearly independent, so not a multiple of one another. So what we do in order to avoid that situation, we introduce x. And therefore, the general solution is C1 e power Rx plus C2 x e power Rx. Case 3, where you got two complex root R1 and R2. A square minus 4b less than 0, complex root, discriminant. So you will get, when you're talking about root minus b plus or minus b square minus 4a, of course, your C is 1 over 2a. This b square minus 4a, or depending, if you swap it, then a square minus 4b, yeah, because our middle term is a and the last term is b, that thing will be negative. That thing is negative, and that's why it gives rise of complex number, which we have studied in detail last term. So roots are alpha plus or minus IB. It might happen your R is plus or minus I2. So in that instance, beta is 2 and alpha is 0, right? Then you won't have this term because e power 0 is 1. You'll then be simply talking about cos beta x sine beta x, if that happens. Otherwise, the roots are represented by R is equal to alpha plus or minus R beta, e raised to alpha x cos beta x, e raised to alpha x sine beta x, and then we combine our YH as this. So this is a summary of what we already covered. So where it is useful, this is your step 1. Okay, then we got a set table for the second step for YP. Okay, there are a couple of table values that we will go through. Get the particular solution YP related to fx because it's inhomogeneous. Homogeneous was discussed last week. Inhomogeneous. So what we are saying is the right hand side is non-zero, where fx will generate some value depending on a type of fx. Whether your fx is constant, right? Then we follow this thing. YP is simply a if it has two non-zero real roots, or x power m or any polynomial in x. Again, we are talking about fx. It could be ft as well. Okay. Here we are talking y is equal to fx, y is equal to ft. If x is equal to f of p, it could be different variable. Just identify what is your independent variable. In this case is x, and dependent variable is y. It could be a cos or sine combination, either cos or sine or any combination. It could be a e power lambda x, some powers of exponential, or e lambda x cos e lambda x sine, or a combination. And the final case is axm e power lambda x. It could be one of the 6 types. Of course, there is a different set as well, which I'll talk in a while. Then what will be the form of your YP? How does your YP looks like? So first, if it's constant, then you are talking about some capital A. I'll explain some examples here, so don't worry. If it is a polynomial, PM, it could be simply one term like this, or it could be a polynomial, right? Then, as it says, it could be cos and sine combination. Now, only cos, then you leave A is equal to 1 and B 0. Only sine, you leave A is equal to 0 and B is equal to 1, or any combination of A and B, right? You must observe this condition. Your n should not be equal to beta. Otherwise, again, the linear dependency comes in, right? Lambda x, then YP is A is to lambda x. Of course, lambda should not be equal to any of the root R1, R2 obtained in step 1. That is, lambda is not a root of characteristic equation. What happens if it is? Again, we'll look at that later on. YP, if it is like this, e raised to lambda x cosine, A cosine x, B sin n x. And again, the roots are lambda plus or minus in, right? Are different from this. So A is not lambda, B is not n. Okay. YP is A PM x, A raised to lambda x. Lambda is not R1, lambda is not R2. Therefore, lambda is not a root of characteristic equation. Okay. Let's look at some examples. Y double dash minus 3y dash plus 2y is equal to this. If you summarize all the weeks, which I'm doing it, I'll finish it and then I'll upload in a Moodle, then you'll understand, how every case is different. So previous week, what we were talking, where your right-hand side was only 0, and these three cases that we discussed, these three cases were arising. You just convert into characteristic equation, and based on this discriminant, you talk about its root, right? Here, right-hand side is non-zero, and that's why we call it inhomogeneous ODE. It's a second order because we are talking about y double dash, right? You have to remember the table. Of course, not memorizing it, but keep it handy and keep referring to it. So what is your right-hand side? It's a polynomial, px or fx we call it, is a x power m polynomial in x. So that's of this form, okay? It's a 3 degree. Degree is the highest power, okay? So what we do here, let's look at the example. First of all, let's follow the step-by-step thing. So we know it's an inhomogeneous second order ODE. So we'll follow this method of 4 steps. What were the 4 steps? They were here. Step 1, first of all, we find the characteristic equation. Then we get the YP based on this table that we have just seen. Then we combine it. And is there an initial condition? No initial condition. So we'll leave the constant as C1, C2 as it is, right? Step 1, which we call it S1, is a step 1, yeah? We convert this into a characteristic equation. It's a second order. So we talk about R squared minus 3R plus 2 is 0, okay? Right. We get two roots, r minus 1, r minus 2 is 0. They are distinct root. So follow this case 1, distinct root. The solution yh is c1 e raised to r1, which in case is 1, c2 e raised to r2, which is 2, 1 and 2. Yeah. R. And therefore, your yh, which is c1 e raised to r1 x, I'm just writing it here. And therefore, yh is c1 e raised to x, c2 e raised to tx. Don't worry if you swap r1 and r2. That's perfectly fine. That is your first step. That's what we are doing, right? Now we continue with this thing in the second part. What will happen? Your step 2. Let me do it in the next page. Step 2. We have obtained our yh, right? Step 2. We have to follow that table up here. If it is m power am minus 1, go up to a0, the constant. So what it will be here? So your yp will be, it's a 3 power. We'll start with a3x3, a2x squared, a1x, and a0. Okay? Because our fx here is 4x3 minus 1, so it's a third power polynomial. Okay? 3 degree third power, whatever you call it. Now, what is our equation? We'll have to plug in there to find this a3, a0, whatever we can. Okay? So what do we need? We need y double dash, we need y dash, and y we already have it. Okay? So yp or y is the same thing. Yeah? You can keep talking about yp, or if it bothers you, simply talk about y. Yh, yp, they are all symbolic to give you an indication of, are we talking about homogeneous or the particular solution, right? It's differentiation. So 3a3x squared, 2a2x plus a1, constant differentiation is 0. We also need y double dash. That will be 6a3x and 2a2, right? We plug all this into our ODE, the given. I'll write it here, y double dash minus 3y dash plus 2y is equal to 4x3 minus 1. We plug all this in this equation. So y double dash, which is 6a3x plus 2a2 minus 3 times 3a3x squared plus 2a2x plus A1 plus 2 times y, which is A3x3, A2x squared, A1x, A0 is equal to 4x3 minus 1. Now we will compare the coefficient. If you want, what you can do is plus 0x squared plus 0x minus 1. So it will be easy to compare the coefficient. And what we learned last term, linear differential, linear equation, simultaneous set of linear equations, simultaneous linear equation, we solve it, right? By back substitution. If it is very complicated, you can always go for there's Gaussian elimination or back substitution or Gauss-Jordan elimination, everything that you learn, right? Right. I'll just do one more steps here. It may find it clumsy, but I'll use different color. Let's talk about x power 3. So where do we get x power 3? That's the only term with x power 3, isn't it? Right? And that's the x power 3 term here. Okay. Now I'll use the blue color. For x2, this is x squared. This is x squared, and this is x squared. Right? Now I use yellow. Sorry for that. X terms. So this is x terms. This is x terms. This is x terms, and this is x term. And finally, any color that I haven't used, black. Let's go for black. Constant is A2. This is A1, A0, and that will be minus 1. Okay, so we combine it. When you flip the place, please make sure you are getting it right. Okay, so what it will look like? It will look like, okay, so that will look like, let me go back to the normal color. 2 A3x3 2A2 minus 9 A3x squared, just combining them, right? Plus 2A1 6A2 6A3x plus 2A0 3A1 2A2 is equal to 4x3 0x squared 0x minus 1. Whatever is missing, you can include it without imbalancing the equation, right? You can do any adjustment as long as the equation is balanced. So you needed something to compare with x squared, so you write 0x squared. 0 times anything will be 0. Not anything, almost anything. Like 0 times 0 is, 0 times infinity is different thing, which is called undetermined form, which we are not discussing here. Right, 0 times x, that's still 0, right? Now we compare the coefficient. On comparing, what you got? 2A3 is 4, which I will straight away give you A3 is 2. Great, right? Next equation. 2A2 minus 9A3 is 0. Therefore, A2 is equal to 9 over 2A3. 9 over 2 times 2, therefore is 9. So you get your A2 is equal to 9. Right. A2 is 9. Next, 2A1 minus 6A2 plus 6A3 is also 0. Therefore, your 2A1 is equal to 6A2 minus 6A3. 6 times 9 minus 6 times 2. 54 minus 12. 54 minus 12 is 40. Yes, that's 42. Did I get it right? Or did I miss something? Looks right. Yep, 42 divided by 2. So 2A1 is 42. A1 is 21. Right? The last thing. Again, when you flip it, please make sure you are copying it correctly. So 2A0 minus 3A1 plus 2A2 is -1. A1, what is A1? A1 is 22. A2, what is A2? A2 is 9 -1. So 66 minus 18 minus 1, that's 47. Did I get it right? So, sorry. Therefore, A1 is 21. So that's 63 minus 19. That will leave us with 44. And then A0 is 22. Right? Finally, your YP. Again, YP is a symbol. You can talk Y as well, which was A3X3. Substitute all the values that you obtained. So that is 2x3 plus A2. A2 was 9x squared. A1 was 21x and A0, which was 22. That is your YP. And step 3, your general solution Y, which we call it YG. S3, I just write S3 is step 3, which is YH plus YP. Just combine it. What was YH? Was C1 e raised to x plus that is your general solution, YG. If there was some initial condition given, then we will get rid of C1 and C2 using those conditions. Most likely they'll be given as y of 0 is equal to something and y dash is equal to something. Yeah. Hope we are traveling good so far. Let's look at the next example. See, this is what I mentioned. This is how it will be given. Y of 0 and y dash 0 is equal to something. So y double dash plus 2y dash plus y is equal to this thing. This is apart from the table, so we don't have to go back every time. So y is equal to a e raised to lambda x sort of thing, which this is. Say I told you t or x, they can be independent variable, right? Then everything will be in form of t. Please make sure, don't mix t and h, x and y and everything. Only two variable at a time. Right, so yp is a e raised to lambda x, in our case a e raised to lambda t, because the dependent variable is t. We just have to make sure lambda is not the characteristic equation, right? It's not a root of the thing. What is our lambda? Is -3, right? Here it's -1 as a root of the characteristic equation. So that should be fine. Okay, right. First step first. Those who are watching recording, please pause it here and do it, right? Step 1. We got y double dash plus 2y dash plus y is equal to 0, homogeneous equation. From that, we got r squared plus 2r plus 1 is 0. Therefore, r is plus 1 square is 0. R is equal to -1 repeated twice from that slide, second row, right? So my YH will be C1 e raised to minus t, C2t e raised to minus t. Okay, right. What we do next? You can obtain that condition from here if you wish, or you can just do it in step 4. Because if you follow the steps, what it says, let's follow the steps. It says here that define the constant by initial condition if required, right? So we follow step 1, which we obtained. You could have merged this step 2 after step 1 if you wanted to, right? Get a particular solution, because particular solution will not have any constant because of how we compute it. Then yg is yp and yh. Okay? Okay, that's fine. Let's go here. Let's follow the steps as given, right? S2, step 2. What is step 2? The particular solution. What we do in a particular solution? We follow this table thing. Yp is a raised to lambda t. Right? You just have to make sure lambda is -3, your roots are -1, which is lifting, and that's is not a root of the characteristic equation. Right? So you can write down if you want, lambda is -3, your R is -1. So we can go ahead, Yp is A e raised to minus lambda t. So A e raised to -3t. Yeah. So not minus here, sorry. Only, yeah, a raised to ax, right? What we need, you need y double dash, y dash, and y to equate. Same process that we have done now. Okay, y dash will be -3a raised to -3, and y double dash will be 9a e raised to -3t. Y double dash plus 2y dash plus y is equal to, what do we have? 4 e raised to -3t. Plug all the values. So 9a e raised to -3t plus 2 times -3a e raised to -3t. So 9a minus 6a plus a. E raised to -3t is 4 e raised to -3t. E raised to -3t exponential is never 0. You can get rid of it. So 9 plus 10. So 4a is equal to 4. And therefore a is 1. If your a is 1, your finally yp, which was this, is e raised to -3t. That's our step 2. Now step 3, we combine it. Yg is equal to yh plus yp, that is c1 e raised to -t, c2 t e raised to minus, you could have combined it if you like, plus e raised to -3t. This is yg. We would have stopped here if there is no initial condition. But in our case, it is here. What is step 4? Initial condition. So y of 0, which is 4, and y dash 0, which is -2. So we differentiate this. Y dash with respect to t. Yeah, t is our variable. So minus c1 e raised to -t. Here we have to use the product rule. So c2 e raised to -t minus c2t e raised to -t. Differentiation of t is 1, and e raised to -t is this, -3 e raised to -t. Right? Okay. Now we got the differentiation. We are getting two equations because we got two unknowns, C1 and C2. In order to solve them uniquely, we need two equations, right? Y of 0 is 4. That is T0, yeah? C1 e raised to 0, C2 0 times e raised to 0, plus e raised to 0 is 4. This is C1, 0, plus 1 is 4, leading you C1 is 3. Okay, so we got our C1 as 3. Good. Now we use this y dash and the second part. Y dash of, what is our y dash in the simplified form? C2 minus C1 minus C2t times by e raised to minus t minus 3 e raised to minus t, right? We got our C1 as 3, which we will replace. Y dash of 0 is -2. So -2 is equal to C2 minus C1, which is 3. C2 times 0, e raised to 0, 3 e raised to 0. So -2, C2 minus 3, minus 3, and that will give our C2 as 4. So we got C1 and C2. Final step is to write everything neatly. So y Final solution. What do we got? Yg, or simply y, was C1 plus C2t e raised to minus t plus e raised to minus 3t. That is C1. What was our C1? 3. 3 plus 4t e raised to minus t e raised to minus 3t. That is Yg, or simply y. Okay. Decent question. Not difficult. It's a step-by-step process. You have to note down all the steps and practice every step as you go. Yeah. Right. So we have covered 2 cases. That was, if you look at this table, there are 6 cases. One is a constant. That's very easy. So we are not writing an example for that one. We covered the first case. We covered this one, the third one. Now we will provide an example of rest free in order. So we'll talk about cos and sine combination. So that's our next example. Oops, up here. Right. So y double dash minus 4y dash plus 13y is equal to 16 sine x plus 8 cos x. So that's a combination of sine and cos. We just have to make sure that our characteristics roots are different. So your n, which we obtain from alpha I beta part, is different from beta, right? Cool. So let's start with our step 1. What is step 1? Is we are talking about the characteristic equation. So step 1, S1. Step 1. So y double dash minus 4y dash plus 13y is 0. Characteristic equation r square minus 4r plus 13 is 0. Obviously, as you will see, that is discriminant less than 0. So r will be minus b plus or minus b squared. So that's 16 minus 4, 1, and 13 over 2 times 1. So 4 plus or minus 16 minus 52, that's negative 36 over 2. So 4 plus or minus I6 or 6i, a plus ib, yeah, over 2, and that will result into 2 plus or minus I3. So if we compare, that is alpha is 2, beta is 3, right? 2 plus or minus I3. How do we write our YP in this instance? Sorry, YH. So your YH will be e raised to alpha x C1 cos beta x plus C2 sine beta x. Plug in the value of alpha and beta, C1 e raised to 2x, sorry, e raised to 2x, C1 cos 3x plus C2 sine 3x. That's your YH. Okay, now step 2. You must verify, or at least mention, n is not same as beta. What is n? The multiple inside of the composite function. So in this case, our n is 1. Yeah, n is 1. And beta, what is what? Beta is 3. So obviously, n is not same as beta. This is a condition, right? So our YP, just follow the value from the table. A cos nx, B sin nx, right? A cos x plus B sin x, because your n is 1. This is our YP. We are not given any initial condition, so your step 4 will not be required. Now we have to obtain y double dash, y dash value and plug it in the equation, compare to get the value of a and b. So y double dash, sorry, y dash to start with, which is minus a sin x. Remember, cos differentiation is minus sine, plus b cos x. That is your y dash. And y double dash will be minus a cos x minus b sine x. You can call it minus y as well if you want. Right, now we plug everything in the original question, ODE, which is y double dash minus 4y dash plus 13y is equal to 16 sine and 8 cos y double dash, which is nothing but negative y. If you want, you can also replace the value of y. Let's put value of y. We don't want to keep it like this. So y double dash, which is minus a cos x minus b sine x minus 4 y dash, which is minus a sine plus b cos minus a sine x plus b cos x 13y, which is a cos x plus b sine x is equal to 16 sine x plus 8 cos x. Now we compare cos and sine. Prior to that, we equate or separate it. So let's combine all the cos terms. So this is a cos term here, another cos, third cos, which will be equated with the other one, right? And the sine term. Sine, 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 compared with the sine term. Okay. Let's combine it. So minus a cos is minus 4b plus 13a cos x is 8 cos x. Sorry, my bad. I swapped this thing. That is sine term. And this one is a cos term. Okay. Right. And the other equation, minus b plus 4a plus 13b sine x is equal to 16 sine x. We can still simplify, as you can see here. So we'll do that. So 12a minus 4b is 8. Again, simplify where you can get rid of 4 divided by 4. So 3a minus b is 2. Call it equation 1. Simplify here. 4a plus 12b is 16. Again, get rid of 4. A plus 3b is 4. Equation 2. Now we got two equations. It's up to you how you solve it, right? Substitution or elimination. Let's go with elimination. Multiply equation 1 by 3. So let's rewrite the equation. Here, 3a minus b is 2. A plus 3b is 4. Okay. 3a minus b is 2. And a plus 3b is 4. Times it by 3 and adding here. So 9a minus 3b is 6. A plus 3b is 4. Add them. 10a is 10. A is 1. Choose any of the equation. I'll choose here. 1 plus 3b is 4. 3b is 3. B is 1. Great. We got a and b. Now your yp, which is a cos plus b sine, will be reduced to yp is equal to cos plus sine x. That's your yp. And finally, step 3, which is the combination of yh and yp. So simply yg is yh plus yp. Yg from our earlier thing, e raised to 2x, c1 cos 3x, c2 sine 3x, plus this yp, which is cos x plus sine x. That is your final general solution. We would go with step 4 if we were given one more, we'd go with one more step if we were given particular solution conditions, right? In this case, it's not given, so this is your final step. Right, so we got two more examples to follow based on our table that was provided for specific set of YP. Let's look at the next one. So this is as per, don't worry about 40, but e raised to x sine x, combination of exponential and trig. So that's this part here, either cos or sine or combination. So this is only sine. So how we do e raised to lambda x, a is cos, b sine. Obviously, a cos will not exist here because it's only sine. So we'll only focus on sine part here. We just make sure that your alpha beta from the characteristic roots are alpha is different from lambda and beta is different from n. Right. So let's look at that. Let's step one, step by step. Step one. So we are given y double dash minus 4y dash plus 13y is 0. This is the same equation we just dealt with. So without wasting too much of time, we can say our R is 2 plus or minus I3, which gives alpha is 2 and beta is 3. From here, you can compare it with this. So your lambda is 1 and your n is also 1. So let's define the condition. Alpha is not as lambda and beta is not same as n, which is great. So we can proceed. Right, your YH, the homogeneous part, which was from the previous example. This is from the previous example. E raised to alpha x, 2x, C1 cos 3x, C2 sine 3x. This is your YH. Step 2, we form the YP. YP will be as per this, but we don't have the cos. You can keep it, that will be made 0. Let's keep it for now. Okay. E raised to lambda x, a cos nx, b sin nx. That's our YP. Okay. Now we need y dash and y double dash to put in the original equation, right? So y dash, right? See, this is product rule, right? This is a product rule. Okay. Y dash will be, let's keep the E part as it is. Definition of E is E, a cos x because our n is 1, and b sin x, and e raised to x minus a sin x plus b cos. This is the differentiation, right? This is our y dash. Now y double dash. Okay. E differentiation is E, a cos plus. If you want, you can combine it as well. So you got a bit less steps. So let's simplify y dash first of all. Let's take e raised to x combined. There are two cos terms. So we can say a plus b cos plus minus a plus b sine. What this helps, you won't have 4 steps. You'll have only 2 steps after differentiation from the product rule. Now talk about y double dash. E raised to x is e raised to x. We are not doing anything here. Minus a plus b sine. And now internal e raised to x is e raised to x minus a plus b sine minus a plus b cos. Again simplified. So e raised to x Combine cos, so we got two cos term, a plus b minus a plus b cos. Up here, minus a plus b minus a minus b sin x. A is gone, 2b cos x minus 2a sin x. This is a y double dash. Please be careful when you deal by substituting everything in the original equation. Okay, so let's write down the original equation, which was y double dash minus 4y dash plus 13y is equal to 40ex sin x, 40e power x sin x. Now y double dash, which we just obtained, we can leave 2 outside as well, or leave it inside. It's easy to compare. E raised to x, 2b cos minus 2a sin, minus 4y dash, that is this. So 4e raised to x, a plus b cos plus minus a plus b sine plus 13y. Y is this thing here. Lambda n is 1. So if you want, you can write e raised to x cos plus sine. And that is your y. Of course, yp, but that's the same as y. 13 times e raised to x cos x plus sine x and 40 e raised to x sine x. Okay. Let's separate the cos and the sine terms. Okay. There is no cos term on the right hand side, so we can set the coefficient as 0. So if you want, just write down here plus 0 cos x. Yeah, so it's easy to compare. Now, the cos terms in green. That's a cos here, and that's a cos here, right? For the sine term, that's a sine term, and a sine term will be with this one, okay? Okay, we'll keep e raised to x in front. So this is 2b cos x minus 4a plus b cos x plus 13 cos x is equal to e raised to x 0 cos x. So that will be 0, right? And we don't worry about simplifying it for now. Just combine everything, yeah? You can simplify however you want, as long as you are comparing the right equations, yeah? Okay, e raised to x outside here as well, minus 2a sin x minus 4 bracket minus a plus b sine plus 13 sine is equal to 40ex sin x. Watch it carefully here. Don't worry about ex. Don't worry about cos. So 2b minus 4a minus 4b plus 13. Did I miss anything? No. Is equal to 0. And the second equation, what was our y? Had a and b, isn't it? Sorry, I missed a and b here. So where it will affect 13a cos b sine. So 13a and 13b here. So this will be 13a and minus 2a minus plus 4a minus 4b plus 13b is 40. Right, once you simplify that, 13 minus 4, so 9a minus 2b. 9a minus 2b is 0. And the second equation, 9a minus 2b is 0. Second equation, 13 minus, so that's 9b plus 2a. Yeah, 9b plus 2a. We write 2a plus 9b is 40. You can solve it however you like. Yeah. I prefer elimination always, or in this case is a 0. So what we say, b is equal to 9 over 2a. We put it here, 2a plus 81 over 2a is 40. So that's like 85. A over 2 is this. So a is 80 over 85. We can get rid of 5 from both ends. So 16 over 17 is my a. Right? And therefore b will be 9 over 2 times 16 over 17. We can only get rid of an 8. Right? And that will be 72 over 17. That's our b. So we found a and b. Right? We just write it nicely. Okay. So our yp was e raised to x, a cos x, b sin x, e raised to x. A is 16 over 17 cos, 72 over 17 sine. Keep 1 over 17 outside, so 1 over 17 e raised to x, 16 cos, 72 sine is our yp. And finally, step 3 is yg is yh plus yp. Just write everything combined. E raised to 2x, c1 cos 3x, c2 sine 3x, plus 1 over 17 e raised to x, 16 cos 72 sine. This is your final answer. It's long, you may get lost, but follow the steps. What are the steps? 3 steps. First, you follow YH. YH is the characteristic equation for the corresponding homogeneous. Follow these 3 cases that we discussed. Then talk about, YP based on this table value, because still one more case to discuss, but based on a table value, discuss what it fits in. And finally, combine it, YG plus YP. And if the initial condition is given, then, you um, go further to get rid of your constant C1, C2 in that case. Right? So let's look at our last example. Okay, let's look at our final question where we have y double dash minus 5y dash plus 6y is equal to 4x e power x combination of polynomial and exponential. Right, I'll quickly go to the table and explain something here before I start with the example. Okay, so this is our this case where you got some constant and x power or this. What is this PM? This PM is the same as this PM. Polynomial of degree m. So depending on what you got here, which is the same thing as that, you will replace your polynomial. So if you got x power 3, then you replace this a3x3 plus a2x squared plus a1x plus a0. If you got x squared, then you'll have a2x squared, a1x plus a0. If you got simply x, then you will have a1x plus a0. The constant can be manipulated however you like. If you're not happy with a0, a1, a2, a3, call it PQRS. It's up to you. As long as we don't mix up, we have a clear understanding of what's happening. Okay, so this is our last case for today. Let's go back and do that example, right? So this is AXM e power lambda x is equal, whenever such is a case, we got our YP is A polynomial in x e raised to lambda x, just ensuring lambda that the, exponential power is not same as the characteristic equation. So let's get started. What is our lambda? Lambda is 1 here. Step 1, y double dash minus 5y dash plus 6y as 0, which will give you r square minus 5r plus 6 is 0, r minus 2, r minus 3 is 0, and therefore our YH, the homogeneous, is C1 e raised to 2x, C2 e raised to 3x, right? Our lambda is 1, which is different from 2 and 3. Yeah, which is great. So this is our YH. Nice and easy. Step 2. Step 2. If you simply write what is our YP is A PM, of course, of x, that's a polynomial of x, e raised to lambda, which is 1, e raised to x. Now, what is PM, as I just mentioned, is a polynomial on x, depending on what you got here. So you got x here, so that could be, you could have written your PMX as A1x plus A0. So let's write it. A times A1x plus A0 e raised to x. A1x plus AA0 e raised to x. Now, if you recall from our memory that whenever you get multiple constants, you can always adjust it however you like. So how about I call it, we haven't got B, we haven't got C. Okay, let's call it B and C. Bx plus C e power x. That's your YP. Yeah, that's your YP. You can replace any constant you like, as I said. Now, normal process, once we obtain our YP, we find out y dash, y double dash, plug in the original equation, compare left and right side, and obtain our B and C, right? Okay, so I write y again, y or YP, which is Bx plus CEX, y dash, Bx plus C differentiation is B, e raised to x, or not or, it's like plus this thing. You can combine it. I would prefer to combine it. Let's e power x. So that is Bx plus B plus C. That is your y dash. You call it y dash, yp dash, same thing, right? Okay, now y double dash. E raised to x differentiation is e raised to x, Bx plus B plus C. E raised to x as it is. Bx is B and that two are gone because constant differentiation is 0. I hope this differential makes sense. You're just following the product rule. You should be an expert on the basic thing that you already learned. Okay. Combine it. So e raised to x bx plus 2b. That's our y double dash. Right? Now, our equation is y double dash minus 5y dash plus 6y is equal to 4x e raised to x. Let's plug everything in. So e power x bx plus 2b plus c minus 5ex bx plus b plus c plus 6y, which is 6bx. Okay, let's write e power x first because that's what we have been doing. Just to, so it's easy to compare. 6 e raised to x bx plus c is equal to 4x e power x. Let's combine everything. Right, let's combine everything. Okay, so let's keep e power x outside. That will help us to simplify easily. Again, make sure that when you are combining, you are taking care. When you are flipping, you are taking care of it. Okay, so let's talk about e raised to x. Let's keep it outside. So e raised to x outside. Inside, focus on the x term first, right? How many x term we got? So we got this x term here, an x term here, an x term here, and that's the x term here, right? So that will give us bx minus 5bx plus 6bx. That's all with the x terms. Without the x terms, you got 2b plus c here. Then you got 5 times b plus c with negative, so that will be negative 5b negative 5c. And you got 6c here plus 6c is equal to 4x e power x. Don't worry about e power x. So we got bx minus 5, so that's like 2bx. This one will be simplified as 2c minus 3b is equal to 4x as we get rid of e power x, 4x plus 0, right? So 2b is 4. That will give you b is 2. And 2c minus 3b is 0. 2c minus 6 is 0 because you plug that back here. And your c is 3. So we got 3 and 2, right? Perfect. So that's our yp. So we rewrite yp as 2x plus 3 e power x, right? That's our yp. And finally, step 3 is the general form. So y is equal to yh plus yp. So yh, c1 e raised to 2x, c2 e raised to 3x plus 2x plus 3 e power x. That is the final general solution. It will contain C1 and C2 because we are not given any particular conditions. Okay, so what else we got? That's it. We got some spare slides because I try to condense it. So that's it. Thank you very much. Please practice this. What really saddens me is I see many of you are interested in a support session, which is good, but at the same time, you are skipping the regular lecture. I don't know how that makes sense, where you wanted to cover everything in a half an hour, 1 hour session, but you are not available for a regular lecture, right? Combined effect will be great. I'll see wherever I can provide solution support session, but don't make it that, oh, we'll always go to the support session, skipping the lecture, and that's fine. I mean, it won't always work. Yeah. So, yep, any question, just shoot me an email, but keep practicing this, what we are learning now. Yeah. Thank you very much, and I'll see you next week.